Officially, hi everyone. It's a pleasure to have you all on our AutoScheduler or AutoScheduler, depending on your favorite flavor of English, our webinar. My name is Felipe Dile, as you can see here. I'm a mining engineer working for the Datamine consultants team here in the UK office. And today we're going to present you one of our great solutions for mining engineers or sometimes for geologists, especially for those who work with mine planning. Okay? So these are the topics that we're going to discuss today. First, we're going to go through a brief introduction, followed by an overview about how MineMax Scheduler fits in the mine planning workflow. So a contextualization of AutoScheduler into mine planning. Then we jump into an overview and presentation about AutoScheduler itself. And then I'm going to actually open the software, show you the interface, how the tools are displayed, and how things are accessed inside the software. After showing you an example, its application, I'm going to wrap it up, summarize some conclusions about AutoScheduler, and I hope that you will be able to get to know if AutoScheduler is suitable for your needs or not. And at the end, if you have any questions, I'll be happy to take them and help you however I can. Actually, you can make the questions during the presentation, but I'm going to answer all of them at the end. All right? So, as most of you know, just a brief introduction. Datamine is the leading technology provider for the mining industry. So we have, when it comes to software, because we also have consulting, but when it comes to software, we have a full range of solutions which cover the whole process chain from geological exploration all the way to the operations themselves and commodity trading, ESG, and global solutions here on top. And we have recently expanded this portfolio actually by purchasing geovariance, which is going to reinforce or is already reinforcing our resources management suite. And we actually, we also acquired Auto, which is a ship management software, which reinforces our operation suite, all right? But today, we're here to talk about AutoScheduler, which is a solution that composes our mine planning suite. But AutoScheduler or AutoScheduler actually works inside Studio OP. So it's not a standalone solution. Instead, it's a complementary solution inside the famous Studio OP, okay? So that's a little bit of contextualization, and I would like to point out the difference inside the mine planning suite. So focusing on the mine planning suite, we can split our solutions into two levels of planning, as I like to call. The first one, which many people call long-term planning, I like to call it strategic planning, is where companies take their strategic decision or portfolio management decisions. So, for example, whether to invest on a mine or not, evaluating risks associated with a certain mine site, and all of the strategic decisions. And the solutions we, when I mean we, I mean Datamine, the solutions we provide for this level, the strategic planning solutions, are mainly Studio and PVS, where you do most of the strategic planning, so economical evaluation, sorry about the noise. You also do the creation of automated generation of pushback and strategic scheduling. And for clients who want to make, or who want to use an optimizer, to increase the value of their project. We also provide mine mapping schedule, work specifically on the optimization of the strategic sequence and help making CapEx or investment decisions. So we have the Studio MPVS for overall strategic planning, and we have one map scheduler for optimizing the sequence into strategic planning level. Okay, so when we move on to tactical planning, we stop making strategic decisions and we start thinking about how to perform the targets defined in the strategic planning. So in tactical planning, which many people call medium-term or short-term planning, we start taking care of how our equipment are going to be used, how many days we're going to work, how many hours we're going to work a day. So we start taking care of the details. So since the tactical planning no longer does the same activities, the same type of activities at least, that we were doing on strategic planning, we need other tools suitable for tactical planning. And these tools that we here in Datamine we provide this level of planning are mainly Studio OP, where you do mine design, reserves evaluation, and technical sequence. And for those who want to make use of an optimizer to increase the efficiency of the use of their equipment and facilities, we also provide AutoScheduler or AutoScheduler to work specifically on the optimization of the tactical schedule or tactical sequence. All right. So inside Studio P, what we do is we create a bid design, as you can see here in the left. So we create a design for each phase of our project, of course, respecting the work we have previously done in Studio MPVS. And once our tactical plan is mostly a short or medium-term planning, we need to make it operational. So we need to create mining blocks that make sense in terms of how this operation is going to work. And after I have this mining blocks defined, which are my reserves, I need to define a mining sequence or a mining schedule that I'm actually going to implement. All right, so that's the sequencing part. So as I told you before, the input for the scheduling are the reserves, and the reserve starts with the creation of the phase solids, which are then sliced into benches. As a result, we have what we like to call the bench solids. All right, and when we have the bench solids, we cut them into smaller units, which we call mining blocks. And so in the literature, we can also find these mining blocks being called SMU for selective mining units. But the important thing is that the size and shape of these blocks, these mining blocks, they need to make sense. They need to reflect the mining equipment and the mining procedures that we're actually going to implement, all right? So alongside with the mining blocks, we also have attributes and dependencies. So the attributes are any type of information associated with mining blocks. So these attributes can come from an automatic evaluation of mining blocks or from interactive selection. Okay. So some examples of attributes are block ID, which work as a numeric name for the mining block, ore mass inside the mining block, the waste mass, the ore grade, average, or basically any other information that you can possibly want to associate with a given mining block, with a given volume. So additionally, in this reserves workflow, we define the dependencies between mining blocks or precedences, as they're called in other software, which help us avoiding undercut or undermine and making our schedule more operational, right? So we're constructing the basis for our schedule. So these three types of information, the mining blocks, the attributes, and the dependencies, they are the input for scheduling, and that's why we have reviewed it. And this group is called dataset. So it can be saved, exported, imported, or automatically accessed in the scheduling ribbon inside Studio OP. All right, but that's just the input. But the big question that we're all interested in answering today is, given a certain data set, which includes mining blocks, attributes, and dependencies, as we have seen, what is the best extraction sequence? So in our little example, we should I start with the plots from the left-hand side and go as deep as I can, as fast as I can, using this sequence, or should I start with the blocks on the right-hand side and only start mining a lower bench when I'm done with the previous bench? So sort of a top-down sequencing. What's the best solution? That's a big question for us today. And the answer to that, of course, is it depends. But it depends on a lot of things. It depends on, for example, how many periods you want to use and how long these periods are. So just to make it clear, a period would be a week, month, or quarter. You choose it. So how long is the period that you want to use for your mine schedule? It depends on where you're going to take your material to. So which are your destinations. You'll probably have a processing plant, waste dump, a stockpile. And each one of these destinations have its own properties. So for example, processing plant certainly have a certain capacity. Usually its efficiency varies depending on ore grade or contaminant grade. Also, the stockpile and the waste dump certainly have a limited capacity, etc. So the best sequence also depends on the whole roads that transport material from the pit to the destinations. The best sequence also depends on the equipment that you're going to use to load and transport material to these destinations. Everything influences the schedule. It also depends on the calendar that you're going to use, that you need to respect. So it can be related to a certain days that you don't work in your country, or it has to do with a very intense rain season that you may have in a specific period or in a group of periods where you already know that you're not going to be able to access a certain area because of the rain. So it depends on depends on a lot of things. That's my point here. You can also have environmental restrictions that will only allow you to access or to mine a certain area after you get a mining permit or a license. And on top of that, there's a couple of targets that you define yourself based on what you want to happen in your mine operation. So for example, you might want to feed your mill at a certain predefined amount and then increase this amount maybe later on. You may want to blend material to never deliver only the low grade ore to the mill, but maybe you want you prefer to mix this low grade material with high grade material instead. And you probably would like to increase the value of operation, so try to reduce costs, increase profits, right? So Studio P has a scheduling ribbon, which is used to define all these variables to help you produce a great tactical sequence for your mining operation. So since we have this brief explanation here on a PowerPoint, now we can really go and look at the software and see how it treats this kind of stuff. All right, not jump to conclusions yet. So this is the Studio P. Most of you know it. So in the reserves ribbon, that's where we do our pre-work. We define our mining blocks. We create our dependencies. Then we create a data set. Well, we evaluate our attributes, of course, and then we save everything on this group, this big file, this group of files that is called dataset. Then when we go to the schedule ribbon, we can bring this dataset here in the setup window. All right. So in the setup window, that's where most of the things happen. But before I go to the setup window, actually, I'm going to show you my example of reserves. So this is my reserves. I don't have a schedule ready yet. Just have these reserves. I also have my end surface. So the surface that I intend to build as I create my mining sequence. Okay, so that's my end of the 2 years period I'm going to schedule. And so just so you know, that's my reserves, that's my end period, and I'm also using a haulage network that I've created and displayed in pink here for you. This dash line, this is the haulage network with this very simple example. And I have I'll have a destination here, the dump, waste dump, and the processing plant. All right. So now you know the data that we're working with. Now let's have a look at the scheduling ribbon. It's the setup ribbon of the schedule. So that's here in the data settings is where you bring your data set, so you can easily pick it up. A data set that you have saved or that someone sent to you, and you can create a mine schedule, and you can create a lot of mine schedules if that's something that you want. That's an option. You can create multiple. Then we'll not have time to go very deep into all of these options. There's a lot you can do if you want to make things complex. You definitely can do it. But here in field treatments, it's basically where you establish how each attribute is going to be considered. So usually the default settings are okay, but it's always nice to check if a specific field is being treated as it should. So for some fields, you want to accumulate them. Some fields, you want them to be weighted by another attribute. So that's where you define these things. Then option, you just define how you want the data format to be displayed, and if you want to do data validation or not. If you want to load and save, maybe you want to stop using a certain setting. You don't need to delete it. You can just come here and say, well, keep this setting, but not going to use it for the area. All right. But the main part starts here. So the first thing, as we have seen in the PowerPoint presentation, is the first thing is to create the calendars. So which periods I want to define. So in this case, we're using monthly period. So we have here the definition for each period, and we're having 24 periods of a month each. All right, so that's a 2 years mining schedule broken into monthly periods. Okay. After defining the periods, we can also assign, well, create a mine calendar. So usually mining operations or mine sites have their particular calendar. So for example, maybe you were gonna work 24 hours a day and all the days of the year except for Christmas on this example that I've created. So on Christmas Day, the whole day we're not going to be working in the 2 years that I'm scheduled. Just to give you an example of how we can define non-working days or non-standard days for downtime. Okay. You can also create maintenance calendar, and that's very nice. So for creating maintenance calendar, you have to add, and you can create multiple if that's something you want. So the use for that is, for example, let's say you have a single type of excavator, and you want it to have a predefined maintenance calendar, and that's going to impact on the availability of these machines. So you can define this maintenance calendar here and say, well, this machine is going to be unavailable for the operation from this date to this date during X hours, if that's something you want. Okay, and you can create multiple calendars, and then you can later on assign each calendar to different equipment types or equipment groups, if that's something you want to use. Okay, but in this example, we want to make things, we want to keep things simple, and we're not going to use maintenance calendars. All right, so once we have defined the calendars, we move on to the destinations. So in destinations, that's where we define our processes, stockpiles, and waste dumps. Okay, so in processes, plants, we gotta define a name for this destination. Mine is plant. If it has a maximum overall capacity, we can establish it. We can define a processing capacity, so a limit of material that this destination can receive. And this limit can be per period, per week, however you want to establish it. And if you want to define varying processing capacity, maybe you're planning to expand your processing plant, you can define varying processing capacity here. Pretty simple. You can also define, or you probably need to define, which type of material will be allowed to go to this processing plant. So in this example, we have 4 material types, 4 categories of material, and by checking this box, I'm allowing the software to only deliver this order material to the processing plant, which makes sense. We can also establish constraints by range. So maybe if I had, depending on the material type, the ore that I'm working with, sometimes you have different processing plants for different types of materials. So you could define a minimum ore grade, for example, a gold grade that is going to this processing plant. And maybe if it has a lower or a higher grade, it might go to another processing facility. Okay. You can also use filters, which is a little bit advanced, so we're not going to go through that today. And you can also establish how your recovery of material or your product is going to work. Usually it depends on the series of attributes that are already in your bot model. So you can access and create recovery settings that is specific for your processing plant. All right. So after that, you can configure stockpiles and dumps. We're not going to go through stockpiles today, but it's not that complicated. It's just something that would take some time, but a lot of the procedures are the same for the waste dumps. So both for stockpiles and waste dumps, we gotta give it a name, create this destination, give it a name, establish a maximum capacity, and these ones usually have a limited capacity overall. You can also establish processing capacity per period. So maybe you're just going to have one equipment, maybe one excavator working on each stockpile for reclaiming purposes, and you don't want this to be disrespected, so you can create this processing capacity for a waste dump or for a stockpile. You can also tell the software which type of material is going to the waste dump in this case. So we have fresh waste, soil, and weather material going to this dump, which is called dump basically. And we are not applying any constraint using the attributes that we have in the mining block, okay? If you want to, you can also insert economical or financial attributes in here. So you can assign, for example, a rehabilitation cost for a waste dump or a stockpile. You can establish a processing cost for each processing facility, and keeping on the dump. You can use also use the dump modeling. So if you have designed a dump and you have it broken into dump blocks, you can just use it here, select it, and it's going to bring all of the parameters that you set, and this maximum capacity will be automatically updated and use the volume that you have designed in the design ribbon. Okay, so things are well connected. So once I know all of my destinations, I can configure my machines, and that consists first of all on loading equipment. So you can, of course, you can add as many equipments as you want, but you can, so you would just click here on add, and you can have maybe different groups of machines, and you can configure all of them separately. Maybe you want to assign each one of them to a certain type of material, something like that. But keeping things simple, you gotta give it a name. So I cannot change the default, but if I create other groups, I can of course give them a name. I gotta specify a rated capacity. So how many tons this loader or this excavator can load per hour. If I have an adjustment factor, I can use it. So for example, usually, let's say my soil material is low density, and my fresh rock is very dense. So maybe I can use an adjustment material to adjustment factor, sorry, to account for this density difference that will impact on the rate of my efficiency of excavator. All right. If I had created a maintenance calendar, I could also select it and assign a specific maintenance calendar to a machine group. But once I didn't create the machine maintenance calendar, don't have anything to select here. One other thing is I need to assign this equipment, this group of equipments, to some material types. So maybe I will have big equipment to work on the waste, and I want smaller equipment to work on the ore, just to increase my selectivity and reduce dilution. If that's something you want, you can use this category selection here. It will be pretty simple. Some display options that we're not going through today. And in calendar here is where you define how many units of this equipment you have, which are their mechanical availability, use of availability, and operational efficiency. So all of your operational indexes. and you can vary them by year, which is pretty useful, especially for mechanical availability, because that's something you usually reduce over the years as your machines require more maintenance as they get older. You can also, well, if you're using AutoScheduler, you can also just assign these scheduling settings. You can also define a drilling equipment, but that's not something we're going to use now today, these little examples, because I didn't create a drilling activity. You also need to tell the software about your tread fleet. So, well, that's usable. So every time you want to make additions, so for example, I click here, select and deselect. So I changed something on my previous configuration, and if I'm going to leave this window and go to the tread configuration, the software is telling me, well, you have unsaved changes. You changed something and you didn't hit apply here. So do you want to use this new configuration that you've set or not? You want to discard that? So in this case, I don't want to change anything. I'll just discard it and will not use the configurations that I accidentally changed. Maybe. All right. So moving on to the tread configuration, you can decide a name for this group in your tread fleet. If you want to, you can have multiple groups of treads. That's also something that can happen. If you have a group of, let's say, 10, 20 big treads, and then you also have 10, 20 smaller treads, and you have a tread from a contractor. If you have multiple fleets, you can configure them all here, all right? But in this case, again, we want to make things simple, so we just have one tread fleet with treads with 30 tons capacity. If I want to apply an adjustment factor, I can do it. Maintenance calendar can be assigned to treads as well. And you can also define how many treads you have, how much percent of the time they're available, how much percent of this available time you effectively use this tread, and how effective are you when you are effectively using this tread, right? And you can also assign a cost for hauling a tread in your tread fleet. And this can vary over time, maybe up to the third month, you have a certain number of equipment, and then your equipment availability is reduced because your equipment is getting older or because it's raining, and then the roads become defectuous. But maybe you're going also to acquire a new truck, and then you're going to increase the units. But that's where you configure all of this information, and you also tell the software, well, for this loading equipment here, and this fleet of truck, it takes 2 minutes to load, and the truck usually spends half a minute in the queue. And maybe if you have a bunch of loaders here, maybe you just want this group of trucks to be loaded by a specific loader. So you can also assign and do this match of loaders and trucks in here very easily. You can also define, well, you will need to define a little bit of your truck specifications. So how much, what is your vehicle weight, how the mass distributes in this equipment when it's loaded, what is the coefficient of traction. If you want your software to use all of this information to calculate the speed of the truck, you just keep this assigned, and then you go to performance later on. When we're dumping, also on the waste dump, we can assign some configurations about cycle time in the dump, in the plant. When we're doing reclaiming, we can have cycle times predefined for each destination, but we're not using stockpiling, so we're not reclaiming anything on this example. That's why everything is on 0. And you can also map the performance of your thread either by using a linear relationship or a Vinkel retardation relationship. But basically, you're telling the software how your thread behaves depending on grade of the road, okay? And depending on if it's empty or loaded. All right. So moving on, after we configure the threads themselves, we need to configure, and well, that's actually optional, but you can configure the whole rows. So that's something I have previously done because that takes a couple of minutes. If you want to know more about this, I can show you on a separate section, or if you want to go to YouTube, you can just Google or type into YouTube whole configuration, Studio P, something like that. And you'll have, I guess, 2 videos previously explaining step by step how to do it. But it's pretty simple. You create this bench exits, this feed exits. You create interceptions, destinations. In this case, it don't have point dumps. You create your roads, which are the little segments between each one of these points. You create sectors, and you can save it or export this network or even import it from someone else. All right. Okay, so we have configured all of these resources, but we also may want to constrain. And constrain means telling the software things that I want to be respected. So for this little example, I have defined, first of all, 2 targets, 2 types of targets. The standard targets, which are usually related to quality or grade targets. So they're usually related to the destinations. So maybe you have a processing plant that is only effective or efficient on a certain range of grade. You can define that you want all of the ores to be blended so that you can always have material that arriving to the processing plant within the range that your processing plant is effective. Okay, if that's the case, you can assign here, and if you have multiple destinations, you can treat all of them individually if that's something you want. In this case, I'm also, you can create as many targets as you want. And in this case, I'm also using a minimum amount of ore being delivered to the mill. So the ore tons in this case, until the end of my schedule, needs to be at least 1.2 million tons of ore per month in the processing plant. Okay. So moving on to the advanced targets. So that's where you define targets. Well, I don't want to change anything. You can create as many global targets as you want, and you may want to assign different types of targets. You can use bounds, but you can also use maximize, minimize, and other functions. But in this case, we're keeping with the basics. So we're just telling the software, well, in the first semester up to the period 6, I want the minimum of waste material to be 2 million tons a month. And up to the third semester, I want at least 1 million tons of waste in the waste dump per month. Okay, so these are the targets that I have defined. You can also assign, create filters and use it in any other point of your scheduling. You can also create dependencies. Oh, no, I don't want to change anything. Dependencies is where you look into the dependencies that come from your reserves. So usually these settings are okay. So what these things are showing you is this block that is called this number. It needs to be mined 100% before this follower block. So this follower will only be allowed to be accessed if this leader is 100% mined, right? Extracted. If you want to reduce this, if you want to make this fine adjustments in the dependencies, you can do them here, okay? Moving on to active benches, so that's where you define, well, basically, if you use this, you're telling the software, well, for phase one, I have this limit amount of benches that I want them to be active at the same period simultaneously. And it's a little bit of an advanced option. So we're not going to spend too much time on this introductory webinar. And you can also define bench lags. So maybe you want to define how your phases are going to work together. Maybe you need your phase one to be 100% mined before you start phase two. If that's the case, you will use this bench lag configurations. But usually, the real case is people or mine engineers, geologists want to establish like a lag between benches of different phases, okay? And if you want to create different activities, you can create all of them here and change their order. And all of these things will be later on, all of these configurations will be later on used on the real short-term scheduling that you can use EPS to analyze and follow on. All right. So once you have setup done here, the thing you can do even without AutoScheduler is you can come here to select blocks, and you can, well, basically select blocks as the name says. And let's say you want to mine this block. Let's say I want to mine this one. Okay, start with this one. So this block, it has some properties that you can look into if you click on these reserves here. So if you have a look, this block, it has a certain amount of soil. Actually, the amount is 3,000 tons, 124. And this material is soil. It will be automatically taken to the dump. And if I want to assign this material to the period one, so the first month, I would have to come here, click on select, and say, yes, I want to schedule this block to the first period, because that's the active period here. All right? So if I click on schedule, it's going to allow myself to double check this activities that are being created, so that I assign this block to a certain period of time, okay? But the thing is, I don't want to do this sequence manually, because that would take a lot of time, okay? So we'll undo all of the schedule that I can have previously done. If I have some schedule, I want to forget about it. And now what I want to do, and I will even take this this end period surface out, and I want to use AutoScheduler now, because that's where AutoScheduler is coming to help us. We have told the software everything we want to happen, and now but we haven't selected blocks or anything like that. So we can just click here on AutoScheduler, and it's going to open for us this window. And in this window, basically, what we're going to do is to click on New, and it will create a new scenario. You can create as many scenarios as you want. It's quite quickly. You can give it a name. So if you were changing something from the previous scenario, you can just type in the new name. You can decide to use different types of schedulers. So if you want to use another solution that we have here, which is the Summit, which is a cloud-based processing, you can select it here. If you can define the emphasis of your schedule. So I usually run it on optimal, because AutoScheduler is pretty fast. But if you're doing a very complex mining scenario and it's taking you more than a couple of minutes, you can choose to use this faster options here. And then maybe you're not going to have a 100% optimal schedule, but it's going to be done in a couple of seconds. And then when you find a sequence or a schedule that suits you, then you can just come here again, change, create a new scenario using the same configuration and run it using optimal. I usually actually always use the optimal because it's quite fast. So in the status column, the software is basically telling you what's going on. So now it's waiting for me to run. I didn't tell the software to start creating a schedule yet. So it's waiting for me. Then the next column tells me, gives me an option for timeout. But usually schedules take, let's say, seconds or minutes. But if you're doing something really complex, and you have too many mining blocks and too many attributes, different fleets, different stockpiles, all of these things, it might take a couple of minutes. And if you want to the software to have a limited time to run, and then it just stops and gives you the scenario that it has found up to this time, you can define this time in here, but it's usually not necessary. As you have seen, you can do manual schedule if you want, and then you can run AutoScheduler. Maybe you have the interest of doing a manual schedule just for the first month, and then moving on to the other periods. So if you want to, you can, for example, make it manual for the first period and then tell scheduler, well, run the AutoScheduler and respect all of its settings and the use of these resources just starting on period 2. And then it's going to respect the manual scheduling that you have done for the first period. And you can also do the same for the end period. Maybe you want to run scheduler just for the 6 first months and see how things happen to you. You can also decide to use or not use haulage information. So that's completely optional. So maybe you don't even have created haulage network. So it will be no by default. But if you have created haulage network, you can decide to use it or not. In this case, we are using our haulage network, the truck repo curves, and all of those things. In this column, we are telling the software and actually allowing the software to do selective mining, which actually means that the software is allowed to mine, let's say, a percentage of a mining block on a given period instead of necessarily mining 100% each time. So that makes sense in terms of operations. So I just leave it selected as it is by default. So basically, if everything is as you want it to be, you click on start, it starts running, and it usually takes a couple of seconds or a minute, something like that. So the software is telling me, well, we are starting the scheduling. And I wanted to tell you about this. So usually, if I have defined well my configurations and I have been realistic, the software will find the solution that is optimal and respects all of the limits that I have imposed, okay? But if I'm being too strict, if I, for example, if I want to have 5 million tons of ore in the processing plant, but I have told the software, well, my processing plant only has the capacity for 2 million tons in a period, then the software will tell me the message failed because I'm trying to do something that it's impossible mathematically. So we'll have this information, and I'll be able to go back and say, well, maybe I'm being too strict. Let's try and relax some constraints. All right. So it took, let's say, a couple of seconds, and it found a great schedule for us. Then once we have a schedule, I can click on View and see the output files that come from AutoScheduler, or click on Use. So I'm going to click on Use, and when I click on Use, what is happening is the software is bringing this schedule to the 3D view. All right. So let's have a look at the 3D view and see how things behave with this schedule. So now you have seen already that some mining blocks have disappeared and some are colored. So these that have disappeared, they have been mined on the first period, on period 1. So what we're seeing here is the scenario of the mine. It's a picture of the mine at the end of period 1. Okay, I will change this legend, this color settings, just to use this one that I always like to use because it is made for this purpose. It's schedule. Good. So using this legend, I'm coloring. That's just for visual purposes. The information is in the mining blocks available to you. So using this legend, I can see at the end of period 1 what has not been mined in red and what is in progress in this cyan. Okay. And if I move on to the next period, so now I'm moving on period 2. I just clicked on next to see the next period. I can see that some blocks have disappeared and some other blocks are now in progress, and this block has been partially mined, but it has been stopped, so we're moving on to another block. So I just wanted to go back with the initials, with the end surface, and just moving on with the schedule so that you can see how things progress over the time. All right. So that's end of period 4, and that's end of period 5, end of period 6, and you can see that, well, this, I'm not sure I told you, but this reserves, they have 3 different phases. So you can see that this side, which is phase 1, is getting deeper first than the phase 2 and phase 3, right? And we are respecting all of the dependencies and the sequence we have predefined later. And most important thing is we're respecting all of the constraints. So let's have a look. Well, that's just the end of period 12, so end of the first year. And let's have a look at the graphs. So we can use this little graph option here to create some graphs to show us the results of our schedule. So I wasn't very strict, so you will have some things a little not too operational here, but it's just for webinar purposes. So the software is showing me how much ore I'm delivering to the processing plant in blue, and how much waste I'm delivering to the dump facility in red. All right, I can just drag it aside, create another graph. Maybe I want to see my my grades, my gold grade. Let's see how it is. So yes, if you remember, I used a minimum of 2 and a maximum of 3 for gold grade, and this is also being respected. Let's see what else we can use as an output. So the targets, all of the targets that I've defined, they can be used for graph output. So in this case, I've just created one graph, which is the minimum for waste, and I'm respecting that. If you remember, well, except for this period that I don't have waste enough. So I have defined that I wanted, if you remember, 2 million tons of waste on the first semester, and 1 million tons of waste until the third semester, which is period 18. So all the targets were respected. Okay, one other output that you can have is the haulage. So this haulage, it helps you, well, I will select a mining block to make the example even better. I will select any mining block, let's say this one. This is too big. Want a small mining block. All right, I have this mining block. It has this block ID. It is mostly filled with ore. It has 256,000 pounds of ore. So let's see what is happening in terms of haulage with this block. So this block is, well, it is ore, it's not fresh. So you gotta tell the software what part of the block. So it can, usually a mining block has ore and waste and different types of material. So this one I want to look into the ore. So this is the center of this block. This is the amount of material it has, the volume. That's the name of the block. You can see that it's the same number here and here. So this block will be reaching the bench exit 16, which is one of our bench exit. The distance from the center of the block to the bench exit is 281 meters. So based on the in-bench speed, it would take 0.49 minutes. So all of the times here in this window are in minutes, except the total truck. So we'll take this amount of minutes when it's loaded, and when it's empty, we'll take this amount of minutes to reach the bench exit. And then when it gets to the bench exit, we need to define it here. Just 1 second. We'll say, well, this material is going to, I don't remember if it's speed exit 1 or 2, but let's say it's 2. So it's coming from this bench exit and then getting into the ramp, the main road, and using this segment, which is predefined. So the software already knows it will be taking 0.82 minutes to get into the exit of the pit. And from this exit of the pit, oh, it's not this one, sorry, it's 16 to 1, because that's the pit exit that leads to the processing plant. All right, so that's the time it takes when it's loaded and when it's empty. So the way back, of course. And from this pit exit number 1 to the processing plant, it takes this amount of minutes when it's loaded, when it's empty. And this equipment is being, this block is being transported using this truck, which is truck 1, which is the only one we have in this example. And this is the loader that we're using to load this material onto the trucks. And we have a little summary, which is based on the attribute that we have set. So how much time it's going to spend on queue, time for loading, time for dumping, the total trip time, the number of trips that you're going to have to make with this truck to carry all of the mass on this mining block, the total amount of truck hours that you're going to use to mine this mining block. So you have this information for all your mining blocks for all periods, so for all months. So you have total control of your truck fleet and all of your equipment actually. You can have the same information if you would go to AutoScheduler and then see some other outputs that I'm not going to be able to show you today. You can have the same type of control for loaders and processing plants, stockpiles, this kind of stuff. And you can also export your scheduling results or output your results on an Excel. So you can create from an Excel, you can create dashboards. Sorry, it's been loaded in my other screen. So you have all of this information. So activity by activity, what is happening. So for this block, with this number, we have just one activity, but you could have drilling, loading, transporting, maybe waiting, when this activity is going to start, day and time, when it's going to finish, day and time, how much time it takes for loading this block, how much percent you're going to make on this period, which truck you're going to use, which sector, which ramp it's going to take, which road it's going to take, how much time it takes on this road, what's the cycle time, how many hours you spend on your truck fleet. All of the details are here, and you can create pivot tables on Excel, or you can create dashboards and all of those wonderful things that people do on Excel, right? No, I don't want to save it. You can also output the same thing on CSV if that's something you want, and you can also create end of period surfaces, and that's pretty cool. I'm gonna show it to you very quickly. So in this end of period surface window, you're basically telling the software, well, I like this schedule, so please tell me how my mine is going to look like at the end of each period, at the end of this month, in this example. So you define when you want this to start and when you want it to finish. You give this surface file a name. So I'm gonna create something like end of EOPS for end of period surface webinar, right? And then you click on generate. It will also take a few seconds because it's generating a big file with a lot of wireframes. Then once it generates this file, it has all of the surfaces. So I will turn off the other ones, and I will use some quick filters to display them separately. So this quick filter is a tool that we have when we want to filter what is being shown, what is being displayed in the 3D view, when we want to make it kind of quick. All right, I will select this one. I want to apply this quick filters to this wireframe file, and then I will select this period attribute that it has, and then I will be able to tell the software, well, now I want to see how my mine is going to look like at the end of period 2, so at the end of 2 months, and it looks like this. Maybe I want to see how it looks like at the end of period 6. Oh, I'm gonna hit the auto apply, otherwise it doesn't right? So that's how my mind looks like at the end of the first semester, at the end of the first year, it looks like this. At the end of the third semester, it will be 18. Here we go. At the end of the third semester, it looks like this. And at the end of the 2 years period, it will look like the final surface, of course. And that makes a lot of sense because we have mined all of them at you. There we go. Okay. You can also export this products, these activities that we generated. We didn't focus too much on the activities, but if you really want to move to the short term, you should focus on creating activities and then exporting these activities to DPS, which is our short-term mine planning solution, which is a Gantt chart, and you can synchronize, you can use it in parallel with Studio P if that's something you want. All right, I think I have finished what I have prepared here. Well, I have a little conclusion slide. Will be kind of brief. So in conclusion, I'd like to point out 4 aspects of AutoScheduler. So the first one is the idea behind AutoScheduler is parametric design, parametric scheduling, which means that using this solution, we are no longer simply trying to pick up blocks. Instead, we're telling the software what we want as a result, and if what we want is possible, if it's feasible, the software will output a schedule ready to go, right? The second point is that AutoScheduler has the capability to meet multiple targets and constraints. We had some examples, but of course you can create as many targets as you want, as long as they make sense for your mining operation. AutoScheduler provides you full control of how you're using your resources, so trucks, shovels, loaders, processing plants, stockpiles, waste dumps, etc. And AutoScheduler has the capability to create multiple scenarios very quick, which allow you to adapt new scenarios very quickly as well. Okay, that was everything I had planned for today. Now let's see if we have some questions. Let's see questions. I don't see any questions here. Let's see the chat. Well, I cannot see any questions or comments, anything. Please feel free to make questions now. Well, if you don't have any questions, I'll keep here waiting for a couple of minutes if you have questions. But if you don't, I feel like it's time for me to say thank you for attending to this webinar. It was a pleasure for me to present this nice solution to you. And if you have any other questions or you want to discuss something about mine planning, even strategic planning or tactical planning, short-term, long-term, I'll be happy to help you with anything I can. So that's my email. If you want, just send me an email. I'll be happy to help you. That's it. Thank you very much. Have a lovely day or night or morning, depending on where you are in the world. And thank you very much. Bye-bye.